Oh, we are here again. How was your spring break? Good. I graded your exam. It was so bad that I didn't want to ruin your spring break, so I didn't submit the grade. Yeah, I'm done grading at the beginning of the spring break. Huh? I graded them way before today. I did not post the grade on Brightspace because it would definitely ruin your spring break. Yeah. Like that last exam was the worst exam of all. Like from you guys, I never expected that. My morning student did much better than you guys, which is completely opposite. They always did bad, you guys did excellent. And this exam was like, oh man, they did better than you guys. No makeup, but I decided to have the fifth exam cumulative, chapter 10 and 11. So if you do well in the next exam, I'll replace this grade with the next one. I'm going to give you, but at the end, because I said I'm not spring break. Your exam score was so bad, not you, like overall, the exam score was so bad that I decided to have the fifth exam cumulative, chapter 10 and 11. Whatever you have, the better score, either this exam or the next one, I'll replace the better score with the bad one. Hmm? Yeah. So now you know what to expect from chapter 10. I'm going to give you a question only from the exam. Okay. So whatever you have in your exam, I'm going to give less question in next exam. But you don't have to study anything extra for the materials for chapter 4, exam 4. Study the exam very well for whatever you have in the next exam from chapter 10. Plus, we have 2 more sections, I think, or 3 more sections from chapter 10. We get our test back today. At the end. Because you guys complain a lot. In my morning class, I gave them at the beginning and they were quiet. But you guys always have so many complaints. So I was like, well, I'll give you an exam at the end. I don't want to deal with the exam during class. So instead of giving you the exam now, let's start the materials. And then at the end, before you leave, I'm going to give you an exam back. But I'm just warning you, expect to see an F. Because most of you got F, most. So don't hope for too high. Okay. Before we had our 4th exam, we did addition, subtraction, multiplication of radical. And now today we're going to do division. Unfortunately, we don't know how to divide by radical. So instead of dividing by radical, we actually do it rationalizing. Okay? And to rationalize, wherever we don't want our radical to, we rationalize that. For example, sometimes we rationalize the denominator. It means remove your radical sign from the denominator. Do some tricks so that you don't have to see the radical sign anymore. Sometimes we rationalize the numerator. Means do something so that there will be no more radical sign on the numerator. So depending on what you're doing, we take different steps. Now we have 2 scenarios. Either we have 1 term or we have 2 terms. So here we are going to rationalize the denominator. It means our main concern is the denominator. On the denominator, we have square root of 2. We are okay with 2, but we are not okay with square root. So do something so that the square root will get vanished and you have a simple 2 on the denominator. That's our goal. What can you do so that the square erased? We cannot square because it's against the law. If you have something equals something, then you can square both sides. But here we have only one side, we cannot square. But what can we do so that we get a square? Multiply by itself. So multiply by itself, we get the same thing squared. But math is here. If you multiply the denominator, you also have to multiply what? The numerator. As a result, on the denominator, we have square root of 2 squared. That gives us 2. And you're happy because you have the exact same thing twice. So the 2 power and 2 denominator cancel out. Sorry, 2 power and the square root cancel out. We have a 2 without any radical sign. Then what goes in the numerator? 6 under the square root. We can multiply these two because they have the same square root. As long as you have the same root, you're allowed to multiply the radicand. So multiply 2 and 3, we get 6. And we don't have to worry about that because our goal was to get to the radical sign from the denominator. And we did that. We have it. Okay? So this is for rationalization. Do something so that the radical, there is no more radical on whatever you are rationalizing. The next one has cube root of 7. So how many 7 we want so that the cube root will cancel out? 3. We have only one of them, right? So how many more we need? 2 of them. So multiply top and bottom by 2 of them. Because we want total 3 7. So if you multiply by 2 of them, we end up getting 3 of them, and we are happy. Cube root and cube power cancel out. We have 7 without the cube root. What do you have on the numerator then? We still have our 7 single, but from here, what do we have? Cube root of what? 7 square, right? And what is 7 square? 49. Leandra? I did it before with my morning class, and they were like, well, how did 7 square on the outside got inside, and then how did it become 49? So they were confused. So I was like, well, skip that. Let's multiply individually so you can see why do you have a 49 here? Because you cannot leave 7 square inside the radical. You must expand. So we have 7 times cube root of 49. Outside at the beginning and then inside at the end. As long as the radicand is positive, outside or inside doesn't matter. Are we done? Do you see something here? 7 and 7. 7 and 7. So we can cancel them. That means we left to it only cube root of 49. So in the exam from this topic, I'm going to give one of these. Either it could be square root, cube root, fourth root, fifth root, could be any root, but one of these. So try the next one. Bless you. Ready? So how many more we need? 4 more. Because we want total 5 of them because our root is 5 roots. 5 root means we need 4 extra. So 2, fifth root of 2, fifth root of 2, fifth root of 2. As a result, on the denominator, we have 1, 2, 3, 4, 5 of them. So we put a 5 power. The 5 power, 5 root cancel out. We have the 2 without any radical. And on the top, we have 2 times what? Fifth root of 16. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. We have to roll 16 of them. So 2 times fifth root of 16. And then what happens? 2 cancel out. We get fifth root of 16. So life is easy when you have only one term in the denominator. One more. It doesn't have to be a number. It can be number, variable, or together. So this is an example where we have number and variable together. But the same rule. So what do you multiply by here? Square root of 2x, square root of 2x. We want the same denominator twice. So if you multiply by square root of 2x, we have them twice. The square root, square power cancel out. We get only 2x without any radical sign. And on the numerator, what do you have? 11 times square root of 2x. This time we cannot multiply 11 with the 2x because 11 doesn't have any square root. It's a single number. So we have to just keep them next to one another. And this time we cannot simplify because the one of the 2x is inside the radical, another 2x is free, so you cannot combine them. We can only combine free with the free or underage with the underage. Any question? So one of these will be in the exam, huh? 10 point something, let me see, 10 point what? 10.5, yeah. No, 3 weeks, in 3 weeks. In 5 weeks. Our final is in 5 weeks, wow. Actually less than in 5 weeks. Oh, exactly 5 weeks from 2 days our final, I think. If I'm not wrong. 8 a.m. in the morning. Exactly 5 weeks from today. 2 hours, 30 questions. 8 to 10. So division, we have a big square root. Can you guess our first step? Separate them. Good job. Because our goal is to only get here the root radical sign from the denominator. We don't care about the numerator. And I gave you a hint. Simplify the root first. Why did I give you this hint? See, we can simplify 45. The example we did so far, we could not simplify any of them before. But this one is simplificable. So you split them into two pieces. One is 9 and one is 5. 9 times 5 gives us 45. But we have an extra y, so it goes with the 5. So we have square root of 9 and square root of 5y. That gives us square root of 45y. Do you know what is square root of 9? Today. And this is not simplificable, so you leave it alone. That means this thing is same as square root of 7x divided by 3 times square root of 5y. They're the exactly same thing. And now I know what to multiply by. And multiply top and bottom by what? Just like the last example, what do you multiply by? Square root of 5y. This 3 is whole number. It doesn't give us any problem. Whatever doesn't give you any problem, ignore. Whatever gives you a problem, you only work with that. So we have 3, which is free, no problem. But we have 5y, 2 of them. So we put them as a square. The square root, square cancel out. We have 3 and 5y. So when you combine them, what do you get? 15y. So our denominator is happy. No more radical sign. So you go to the numerator. What do we have in the numerator? 5 and 7, we multiply them. So we get 35xy. Can you simplify 35 with a perfect square number? Can you divide 35 by 4, by 9, by 25? So you leave it alone. It's not simplificable. So square root of 35xy over 15y. We cannot cancel 15 and 35. We cannot reduce them because this 35 is not free. 15 is free. So you cannot combine or simplify unless they are on the same level. You can only simplify free with the free or unfree with the unfree. Question. So life is easy when you have only one term. Now, what happens when you have 2 terms on the denominator? For example, let's say you have square root of 5 plus 1. If you think you can multiply by square root of 5, look what happens if you try to multiply by square root of 5. You have to distribute, right? So you get square root of 5 square, no problem. But when you distribute it to 1, what do you get? Another square root. So for 2 terms, if you try to multiply top and bottom by the square root term, it doesn't work. So that's why instead of using same term, we use something called conjugate. Do you remember what is conjugate? It's the same two terms, just their middle sign is different. So what would be the conjugate for square root of 5 plus 1? Square root of 5 minus 1. So for two terms conjugate, for one term, you just multiply top and bottom by how many you need. The question is, why do we love conjugate? Because we get difference of perfect square, so they cancel out. So we have the first term square root of 5. When you multiply conjugate, the result is first term square always minus your second term square. That's why you love conjugate, because you don't have to use FOIL. Yes, you can use FOIL, but you don't have to. The purpose behind conjugate is to have these. Both of them square and minus sign between them. So what happens to the square root and square power? Cancel out, we get 5. And what is 1 square? 1. And then at the end, what is 5 minus 1? 4. See? On the denominator, no more radical. On the numerator, let's keep it, because sometimes we can able to cancel the denominator with the numerator. So let's not multiply here. If you want, you can, but sometimes actually you can cancel them. Here we cannot, but sometimes we can. So just to be safe, don't multiply them, leave them alone. Kimolsia. Where? What is square root of 5 square? And what is 1 square? That's why we use conjugate, because we can use square. So for two terms, yes, conjugate. Before going to the next question, let me give you one more. Let's say we have square root of 3 minus 1, and you're dividing by square root of 2 minus, let's say, square root of 5. So what do you multiply by? Of the denominator or numerator? Which one? Denominator. So what's the conjugate of the denominator? Square root of 2 plus square root of 5. It's the exact same two terms, but their middle sign is different. So what do you get in the denominator when you multiply the two conjugates? Square root of 2 squared minus square root of 5 squared. That gives us 2 minus 5. which is -3. What do we do on the numerator? Now we have 2 terms by 2 terms, so let's multiply. √3 times √2, √3 times √5, so plus √3 times √5 minus 1 times √2 minus 1 times √5. Hmm? 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 The first one is 3. What, Leandra? Square root of 3 times square root of 5. What do you have? Square root of 3 times square root of 5. 15. And square root of 2 and square root of 5. In order to add or subtract, what do we require? 2 things, right? They have to have the same radical sign and same inside. So do you see any of them have same inside? Can you simplify any of them? Can you divide 6 by 4? Simplify, we can simplify if it's divisible by a perfect square number, like 4, 9, 16, those. None of them have perfect square number in them, and none of them are the same inside. So unfortunately, we cannot do anything here. We just rewrite everything. So you can distribute or you don't have to distribute. I recommend when you have 1 term, don't distribute, but when you have 2 terms by 2 terms, distribute when you rationalize the denominator. But we don't always rationalize the denominator. Sometimes we need to rationalize the numerator. For example, what happens when h is 5 here? If h is 5, look what happens here. We have 3 minus 5 plus 4 over 5 minus 5. 5 minus 5 is 0. And we have 3 minus square root of 9. That gives us 3 minus 3 over 0. 0 over 0. It doesn't exist. So for this function, we cannot substitute our h with 5. But let's say there is something very important with h equals 5. We have to substitute h with 5. So in that case, what can we do? Rationalize. If you rationalize the numerator, some miracle happens. So when you substitute h with 5, we don't get anything undefined, we get a real number. That's the main purpose of rationalization. When something is invalid for any x value, we can rationalize. It means change your function somehow so that you can replace your x with the number you want to replace with. So here we are going to rationalize the numerator. That means we don't want this radical sign on the numerator. That is our goal. Do something so that there will be no more radical sign. So observe we have This radical sign represents entire one thing, one term, and this 3 represent one term. So we have two terms on the numerator. Inside the radical, it doesn't matter how many things you have. The radical is always one term, always. So we have radical one term, number one term. Since we have two terms, so we have to rationalize the numerator. What is the conjugate of the numerator? 3 and then plus. See, you made the same mistake as my morning class. Conjugate has only one sign difference. Only one. This radical is one term. We don't care about what do we have inside. Whatever inside, that represent one term. Conjugate means what? Change the sign between two terms. So first term is 3, second term is the radical. The sign you're going to change is the sign between them. The 3 and between 3 and the radical sign. The radical stays same. We don't change radical because radical is one term. But in conjugate, we change only one thing, only one sign, not two signs. If you change two signs, it's not conjugate anymore. It's something else other than conjugate. So keep your denominator. Our goal is to cancel this h-5. So what happens to the numerator? When you multiply two conjugates, what do you get? The first term square minus the second term square. So 3 square and square root of whatever you have, that square. Square root and square cancel out. We fulfilled our goal. We reached to our goal. But then you have to simplify. Since inside the radical we have two terms, so we need to have a parenthesis. H minus 5, 3 plus square root of h plus 4. Why did I put the parenthesis? And what happens when you subtract two terms? What happens when you subtract more than one term? You have to distribute the negative. So it's minus h minus 4, not plus 4. H minus 5, 3 plus h plus 4. What do you want the numerator now? What is 9 minus 5? What is 9 minus 4? So it's 5 minus h. 9 is positive. H minus 5, 3 plus h plus 4. If you cancel, what do you get? So, Linda, you said 1. 5 minus h divided by 5 minus h is what? The exact same thing, right? So when you cancel, you get 1. But now you don't have that. You have 5 minus h over h minus 5. Are they exactly same? What's the difference between these two? Their sign. So since the sign is opposite, here 5 is positive, here 5 is negative. So it's opposite. Here h is negative, here h is positive. So it's opposite. So they're same, but negative of one another. So when you cancel them, yes, you can, but the answer is -1. So you have -1 over 3 plus square root of h plus. And now look at the miracle. If you substitute h with 5, we get -1 over 3 plus square root of 5 plus 4. 3 plus, what is 5 plus 4? 9. And what is square root of 9? 3. So what do you have? -1 over. So why did we get something undefined before? The denominator has h minus 5, so you cannot have h equals 5. So what did we do? Got rid of our problem, and then we resubstitute it. Huh? Why does it? This one is 3 plus, because our conjugate before it was given 3 minus. Now question what? Okay. At the beginning, we had h minus 5. So when h was 5, 5 minus 5 is 0. We cannot divide by 0. Dividing by 0 is undefined. So when we try to substitute directly, we get something undefined. So we realized our problem is lying on the denominator. Do something so that the denominator gets cancelled out. So we rationalize the numerator. As a result, we got 5 minus h on the top, and we could cancel our denominator problem. So we got rid of the problem by canceling, and now resubstitute. Now it's fine. So it's like you have a bad child. In order to make him good, you send him to some harsh school. So they beat him up, do whatever they need to do, and then give you something good who listens to you. Okay? Any question? So these type of questions sometimes come in the final, not always. Final, sometimes. So I'll put this question in the exam. So one with the one denominator and one with 2 terms on the numerator or denominator. It could be any of them. But you go the same thing, rationalize the top and bottom, cancel, and then resubstitute. Let's do one more, and then you'll be done with 10.5. Rationalize the numerator. It means do something so that there will be no more cube root on the top. What can you do so that there will be no more cube roots on the top? You definitely need to multiply by cube root. That's a fact. The question is, you need to multiply by what? So that at the end, the root will get cancelled out. You can do that. Hmm? I did that in my morning class. It became longer. So can you do something so that you can finish in one step or two steps? Go ahead. What idea you have? Okay, no problem. Let's say a cube root of 2 and cube root of x to the 5. Let's put a little bit here. It's actually a good idea. Look at them separately. Do you really need two of them? So we have x to the 5 and we are doing cube root, right? Remember the simplification we did for our exam 4? If you were not rationalizing, but simplify this. How do you simplify this? Does x square help you? Oh, yeah, x square. And what? 3 of them, right? You put 3 of them together and then 2 of them, right? Why did you do that? So that you can cancel out. Now we are going to do the same concept. We have 5 power, we cannot cancel with 3. So what power we actually want so that you can cancel with 3? But we want more so that you can cancel all of them. We have 5 x's, right? 5 of them. Only 3 we can cancel out. But we have still 2 of them extra. Now we need to add something so that all of them get canceled out. One more. We just need one more x. That's it. One more x. If you have only one more x, what do you get? Cube root of x to the 6. And what is cube root of x to the 6? 6 over 3. That gives you x squared. See? We didn't need extra 2. We didn't need to multiply the same thing twice. We only needed one more x. Only one more x. So I'm going to redo them here. So I need to multiply, we know definitely by x. Now let's decide here. Because our goal is to cancel this radical. Do whatever you need to do so that there will be no more radical. This is rationalizing. Cancel the radical. Now if you want to cancel this radical, how many more 2's we need? 2 more 2's. So 2 times 2. So at the end, we have cube root of 2 cube, and cube root of x to the 6 on the top. That means what was extra? We added. Two 2's, which gives us 4, and an x. So that's all we needed. That's it. We didn't have to multiply top and bottom by extra so many of them. Yes, you can. I did it in my morning class. And I'm going to post the lecture video on YouTube. So you can see how it happens. It becomes longer. And I didn't want to do longer way. So let me erase this because this was for explanation. So for the first step, we have 2 of them, but we need 3, so we added 2 of them. We have 5 of them, which is not divisible by 3, so we need only 1 more extra, so we can divide by 3. So at the end, we only needed to add extra 4 and x. As a result, on the numerator, this cancel out. I mean, they don't cancel out, they become 2. So 2x squared, because this thing is x to the 6 over 3, which is x squared. And the denominator, we can't do anything, so we just leave it alone. So this is a different design, different method than what we did so far. Whatever we did so far, we would use only that method. I mean, not only that method. That was one of the methods. And this is another method. Go ahead, Leanna. What did we need to multiply by here? 4 with the radical side, inside the radical, right? So we have to have this 4 inside the radical. We didn't multiply the 2 and 2 outside the radical, right? We multiplied inside the radical. So when you put it in the denominator, you have to put them inside the radical. And same thing, we put this extra x inside this radical. So this x goes inside the radical. Which one? We are given 5 of them. We just need one more so that we can divide by 3. So this is the extra one more. So you wouldn't you can. Okay. But and then the others you might have to do. What is 2 times 2? Oh. Good news, I'm not going to get this in the exam. But in your homework, you have to do this. And in the quiz. And now you know, right? You have to have your homework as high as, with as high score as possible if you want to pass this class. Especially if your in-class exam is bad, you definitely want to have 420 in your homework. And then quiz as close as possible to 290. With this, you are done with rationalizing. Now we are going to do something that will be in the final exam. Solve rational equation. Something like this. When you solve rational equation, there are 2 things you have to remember. One thing, you cannot apply the power until your radical is alone. When your radical has something in the front, something on the right side, it's very powerful. You cannot touch that. So in order to make it weaker, it's like bodyguard, okay? When radical has some type of bodyguard in the front or on the side, it's very powerful because it has bodyguard around it. So we remove all the bodyguards one by one and make it single, make it alone. When it's alone, then we shoot it with the power. As a result, the radical and the power dies. And we get something with no radical. The second thing you have to remember, once you solve your equation, you must substitute back into the original function to see if the answer you got is valid or not. Just because you got something, it doesn't mean it's right, just like the rational we did in our last exam. When you get something, it doesn't mean it's right. You have to check whether it's right or not. So these are the most important 2 things for the radical. Now let's look at this example. We have square root of 2x minus 3 minus 1 equals 8. Now the radical square root, it has a bodyguard minus 1 next to that. So you cannot touch that until we remove the negative 1. So we add 1 to both sides. We get the radical alone in one side and 9 on the other side. And now it doesn't have any bodyguard, so it's weak. So we apply the square power on both sides. The square power, the radical, they cancel out. We have only radicand without any power, so without any radical. And the other side is just 81. And it's basic algebra. We add 3 divided by 2, we get 42. Now, just because we get 42 doesn't mean our answer is correct. We have to check to see if that is correct. So we go back to the original equation, we substitute 42 here, and then check. We see, yep, our left side gives us same number as the right side. So two things to remember: make it alone the radical and check. And we actually check only for even root. If you have an odd root, you can ignore the checking. Why? Because odd root has domain everything, but even root doesn't have domain everything. It has a specific domain. So your answer has to lie inside the domain. That's why. Now let's do an example. Question number 1, is our radical alone? No. How many bodyguards it has? 2. One is in the front and one is on the right. Which one we get rid of first? The minus or the plus 8? The plus 8. We subtract 8 from both sides. So this bodyguard removed. What do you have on the other side? -10. But we still have one more bodyguard, right? So how can you get rid of this bodyguard? Either you multiply or divide, doesn't matter. Do something so that it get vanished. So we have 20x equals 10. And now it's alone. Like the president, he doesn't have anybody get around him anymore. And I know, like right now, so many people want to kill him, right? It's a reality. But who gets successful? Who can kill this president? Square. You cannot apply any other power. Only the square is eligible to cancel it. So they will die. We get 20x equals 100. How do we divide by negative? You can divide or multiply. Negative means -1. So to get the epsilon, what do we do now? By 20. Are we done? We must check. So square root of 20x plus 8, the result has to give us -2. Do we get -2 if we replace x with 5 on the left side? So this is 5. We get negative times square root of 5 plus 8. What is 5 times 20? 100. And then we have square root of 100 is 10. And what is -10 plus 8? -2. Do we have the same thing? Yes. So x equals 5 is a valid answer. But this is too simple. So expect not to see this in the exam. What you're going to see in the exam is something like this. And also, this will be in the final. In the final, there will be definitely one solving radical equation. 30, total 30. 7 to 6 space. So I do one heading, more question, but they don't have save space. They do 3 questions in 1 page, so more than 10 pages. And gives me heading to check everything. When I check, when I grade, I get 1 page at a time for everyone. So I have to grade 30 exam 30 times. Like, man, it's too much. So that's why I put my in-course exam 4 pages, maximum 6. So I have to get only 6 times 30 exams. Okay, is our radical weak or strong? It's strong. So what bodyguard it has now? Minus x. So we need to get rid of that. How can you get rid of the minus x? Plus x. See, try to remember the story. You don't have to memorize anything. If you remember your story, you know how to solve anything. You need to get rid of all the bodyguard of your radical. Whatever radical you have, get rid of all the bodyguards. One by one. You cannot take everything together. You have to be one by one. You have to be smart. On the other side, you have negative 2 plus x, which is same as x minus 2. Now is our radical alone? It is alone because it doesn't have anything in the front or anything on the side. As long as you don't have anything on the front or side, it's alone. That means you can hire a gunman to shoot it out. See how nice story? You don't have to memorize anything. So the gunman shoots the radical, no more radical. See? All these rules you have for exponent, did you ever see any rule with the plus and minus and between them? You've seen 2x, you've seen 2 divided by x, but did you see anything 2 minus x or x minus 2? There is no rule for x minus 2 square. Okay? Power means you have the same base twice. So it's x minus 2 times x minus 2. So you don't distribute the power, instead you use FOIL to distribute. So we have x times x squared and then minus 2x minus 2x plus 4. So how many x's we have? Minus 4x. So 2x minus 1 is x squared minus 4x plus 4. So the 2 terms becomes 3 terms when you FOIL. And we've seen this structure before, right? So what do we do now? You're solving, right? So in order to solve, what do you have to see in one side? 0. Do you see 0 in one side? What can you do so that you can see 0? Subtract 2x, add 1. So it's a solve for x. So now we have 0, and we do that actually when we have more than 1 degree. Highest degree is more than 1. Bring everything to one side. We didn't do that in the last one because our degree was only 1. So we could simply simplify. But here we have 2 powers, so we need to factor. So what do we have? Plus 5. Is it factorable? Multiply to 5, combine to 6. 3 times 2 is not 5. When you multiply, it's 5. plus 5 and plus 2, right? If you do plus, did you say 2 or did you say 1? Which one, Robert? First of all, 5 times 2 is not 1. So if 5 times 3 is not 5, 5 times 1 is 5, right? So it's definitely 5 and 1. But do they get plus sign? Definitely 5 has to be minus because the middle sign is minus. So then 1 has to have what sign? Minus 5 plus 1. Does it give you minus 6? Minus. So you have to consider both middle and the end. Oops. So it's minus 5 minus 1. So I would suggest always start with the constant. Find two numbers that multiply to constant. Once you have this, then see how can they make the middle term. What do we do next? We separate them. So x minus 5, 0, x minus 1, 0. That gives us x equals and 1. Let's say you see these in the multiple choice and you select that. What do you think you're going to get? 0. Why? You must check. Otherwise, you don't know whether both of them work or one works or none of them work. Sometimes none of them work. Sometimes one works. Sometimes both of them work. So which one is this? You must check. So we have 2x minus 1 minus x. The answer has to give us -2. And since we have two solutions, we have to check twice. For the first one, every x you see is 5. For the second one, every x you see is 1. So 2 times 5 minus 1 under the radical minus 5. This one is 2 times 1 minus 1 under the radical minus 1. So 2 times 5, 10 minus 1 under the radical minus 5. What is 10 minus 1? So 9 under the radical minus 5. What is square root of 9? 3. 3. And what is 3 minus 5? -2. Do you have the same thing? So we accept this as our solution. Now let's see what happens here. 2 times 1 minus 1. So what is 2 times 1? And what is 2 minus 1? And what is square root of 1? And what is 1 minus 1? Do we have the same thing? See, we got the answer x equals 1, but it doesn't satisfy the given condition, given question. So you cannot accept that. That's why you have to check. This is our only solution. Only solution. Now let me give you an example. I'm going to post the solution, but I'm not going to go over. I will tell you the situation instructors to go over the exam on Friday. And you need to go over the exam because you're going to see them again in the next exam. No, I'll reduce the number. I'll put the questions which most people got wrong. Giselle. She's the only one who got 100. I think. Yeah. Stephanie? Brianna, Texas? Me? Mohammed? Here, listen. Kevin? Andy? Christine? Christine, Daniel? Belgelis? Katie? Candice? Catherine? No, but you weren't here. Really? Huh? Mazari? Govan? Robert? Leandra? Timelcia? Yvette? Kasim? Brianna? Madison? Me too. Put together. Jolene, Hassan, Melvelis, Katie.
I gotta fill up one again for the last.
For
I think the third exam.
I don't have it today. I'll bring it in Friday.
I think I should. I'll look for one. See if I have it.
Yeah, I think I gave you in the exam. Do you remember? Bye. Really?
Yeah. I thought it was like.